This video is going to demonstrate the packet-based load balancing features. Okay. Compare with the traditional load balancing. So from SD-WAN, Huawei SD-WAN solution provides two options: packet-based load balancing and flow-based load balancing. So we will focus on the packet-based load balancing because which is better than the flow-based load balancing. Even you have one applications through the one link internet or MPLS, you can still do the load balancing because we can split the one application in multiple packets. Okay, so compare with the flow-based load balancing. If you only have one user running one applications, so these applications can only go through one uplinks. Let's switch back to the environment. Okay, from the monitoring, actually you can see the video traffic for internet and the video traffic for MPLS. This is actually the monitoring for the previous test cases for video. Let's go back to the traffic policy here. Intelligent traffic steering. So this time we're going to add another traffic. Okay, we will use UDP traffic to test the packet-based load balancing. Okay, for the UDP traffic, we don't have to customize based on the 5 tuple. We just need to create a UDP traffic, and because UDP traffic also belongs to our signature database, this time we don't have to set up our own UDP based on the 5 tuple. Okay, so which is the general UDP. Identify the UDP traffic within our signature database, and we will implement this UDP application group to the same place. Traffic policy template management. Create a new traffic classifier template. Select the UDP application group. Okay, the last step, we will create a new traffic policy for UDP only. UDP, this will be number 5 for UDP. Okay, so the load balancing, we will set up both internet and MPLS with the same priority. So make sure the traffic behavior, we have to select load balance. As you can see, for the load balancing mode, we provide two options. As I mentioned before, we provide per flow or per packet. The per flow means per applications. Okay, so per packet means for one applications, you can split into multiple packets. Okay, so which is better than per flow. So that's so we will demonstrate per packet. Okay, load balancing. And we will bind the new traffic policy for site 1 and site 2. Commit this new traffic policy. Okay, committed. I've already opened the site 1 PC1 and site 2 PC2-2. Okay, so for site 1, we don't have to do anything for site 2. Okay, for site 1, sorry. So we will send the traffic from site 2 PC2 to site 1. And this time we're going to use the same application called iPop, because iPop have many features. We can send traffic. As you can see, we can send different type of traffic. So we select UDP traffic, make sure we check the local MAC. Okay, to make sure this is the correct MAC in my PC. Okay, 4C-11. Okay, no issue. The destination MAC will be the gateway for this PC. Okay, so it will not be the destination site. So which means this MAC address will be the MAC address of the router. Okay, so we use ARP-A to check the destination MAC. Okay, so because I know my gateway will be the 12.1.1.1, so we will check this. Okay, so this is my gateway MAC address. Compare with the current one, so it's the same. And my source IP address, okay, no issue. This one will be the destination site, site 1 PC1. Okay, and it is recommended to use the source port over 10,000 because below 10,000 for conflict reason, so we don't recommend to use the port below 10,000. Okay, and make sure the source port, this part will be fixed. Okay, the fixed means you only send one flow. If you select increase or decrease, so the source port is always changing, so it will be multiple flow. Okay, so to test the packet-based load balance, we have to make sure we are using the same source port and destination port. It will not be changed anymore. Okay, and make sure that there's no any delay to send the traffic. And we set up the 600 payload. Okay, now I'm sending the traffic. You can see the traffic is increasing dramatically. And from the other side, you can also open the same application IPOP, okay, to monitor whether the traffic we received correctly. Okay, as you can see, from the received rate is around 15 megabits per second. So we are receiving the traffic, and we also send some back traffic. This is very small traffic, don't need to just ignore that. And so this traffic normally I should receive from both uplink internet and MPS around 8 megabits per second. Now let's go to the access router. Okay, this time will be the AR2. So we send traffic from PC2. So we should check the nearest access router. Display smart same command SPR all. Okay, so we send traffic to the destination 11. So this one, this will be the destination site 22. Pin 5 verbose. So we have used this command to test the multiple application demo. Okay. So let's go and find the UDP traffic, whether it is correctly identified or not. Okay, now we can see the UDP traffic appearing. Okay, so for connection ID 1 and connection ID 2, so we already explained in previous video what this connection ID means. Okay, this is meaning internet link and MPLS link. Okay, so we can double confirm display EVPN connection to check. So the connection 1 will be the MPLS link, connection 2 will be the internet link, because we set up the 37.250 for internet, 38.250 for MPLS. Okay. So as you can see, these two uplinks speed is very similar. Okay, they're close to each other because this is for the overlay uplinks. Okay. Make sure. Okay, so till now they are the same uplink speed, no matter it is internet or MPLS. So we come back to the controller side, and after 10 minutes, the controller will display the UDP traffic going to both internet and MPLS. Okay, so the one flow will be split to two uplinks. Okay, so this is called packet-based load balancing. Let me pause the video and wait for several minutes. We'll come back to check. Okay, as you can see, after several minutes, we are able to see the general UDP traffic on both internet and MPLS link. So the speed is around 7.55, so which is the original datagram. Okay. So this is a little bit smaller than that we can see from the router side. Okay, remember from router side, the speed is around 8.5 megabits per second, something. Okay, something like that.